So now that we know a lot about parametric equations, why not throw in some calculus with the mix? Why not? While we're here. While we're doing it. Well, when we graph parametric equations, the graphs have slopes, right? When I did the infinity one, it goes like this. Pick a point, you got a slope. So you got a derivative, in other words, right? The slope is the derivative. So we can find dy over dx's, okay? Yeah, so parametric equations, the graphs of those have slopes of tangents. So we should be able to find the derivative, which, you know, when we talk about the slopes like this, we're talking about dy over dx. All right, so so if I've got a parametric set of equations, graph that, it's got slopes, so it's got dy over dx's, in other words. How do I get those? Well, there are ways we could write it, but what it looks like, it's really fairly simple. What it looks like is just divide both of these by t. Divide both of these by dt. Divide that by dt, divide that by dt. Right, that's sort of what the operations look like. We're dividing top and bottom by dt, do the same thing top and bottom. But anyway, if you think about that, then look at what we've got here. That's the derivative of y with respect to t. All you have to do is the derivative of the y with respect to t. For the bottom, then divide it by the derivative of this thing with respect to t. So you're just going to do the derivative of this, divided by the derivative of that. Find dy over dx, do the derivative of that, divided by the derivative of that. That's what this means. Okay? Okay? I guess we could write it g prime t over f prime t. This is the way they typically do it. Show it, but that's what it is. Okay? So it's about as easy as you would hope it would be. The second derivative now, that's a little trickier, but not too bad. So let's find dy over dx. Parametric, I've got x equals t squared minus 2t. Y equals, I'll change it up, 3t plus 1. So dy over dx, parametric, it's just you do the derivative with respect to t of y, divide that by the derivative of the x with respect to t. It's cake. So the derivative of that with respect to t, 3. Derivative of that with respect to t, 2t minus 2. Done. Okay, so what is the slope of the tangent for this one? X equals t squared minus 2t, y equals 3t plus 1, at t equals 2. Just add a b part to this one. Same parametric equation. So what's the slope of the tangent for those? Well, slope of the tangent is dy over dx, isn't it? So this slope here is going to be dy over dx, which we now know t is 2, or we're given that t equals 2, so it'd be 3 over 2 times 2 minus 2. So that's 3 over 4 minus 2, that's 3 halves.
There's an asymptote at 1.
Yeah, we couldn't do it t equals 1, so there's something funny going on. Yeah, I don't know. It would probably be something, yeah, be a vert, yeah, I think you're probably right. I don't know, let's just see. Slope, yeah, your slope. All right, so here's a similar one. Find all slopes of the tangent line. Find all slopes of tangent lines to the curve x equals t squared, y equals t cubed minus 3t at the point 3, 0. A little bit of a twist then on this problem. Something like that. But again, we're talking about slopes of tangent lines, so I do need dy over dx. Which dy over dx, when I have parametric equations, is you do the derivative of y with respect to t just over the derivative of the x with respect to t. So that's easy enough. It'd be, what, 3t squared minus 3. Derivative of that with respect to t would be 2t. Now, the twist on this one is, to figure that slope out, what do I need? I need t. Am I given t here? What is 3, 0? That's an x comma y, isn't it? Yeah, so I don't have the t. I've got to figure out the t, and I can use that information to figure out t here. Now, t equals 3, x equals 3, so the other one, if you think about it here, we get t either way, but if I plug in y to be 0, it's going to give me 3 solutions, whereas if I plug in x to be 3, that's going to give me 2 solutions. Well, t can't be 3 here and 2. There's only going to be 2 solutions. The most there's going to be is 2 solutions because there's only 2 solutions here. So what I'm saying is use your most simple equation to figure t out here, because the other one can give you an extra solution that's not real. So yeah, we're going to use x to be 3 here. Plug in x to be 3. To find t. To find the t values. So 3 for t, 3 for x in this case. That gives me 2 answers, doesn't it? Plus or minus square root of 3? Which means I'm going to get 2 slopes. There's going to be, one of the slopes is that t equals square root of 3. So the slope for that one would be dy over dx. Evaluated at square root of 3, so it would be 3 times the square root of 3 squared minus 3 over 2 times the square root of 3. Might go down far enough there, but that's going to be 3 times 3 minus 6 on top, whatever that is. Oh, yeah, simplify that. 2 goes into the 6, so it's 3 over square root of 3, or however you want to write that. But then I have another slope, t equals negative the square root of 3. The slope there would be what? Well, it would be 3 times negative square root of 3 squared minus 3 over 2 times negative square root of 3. So again, I'm plugging in t, but in this case, t is negative the square root of 3, which doesn't give me a different slope because that's 3, that's still b times 3 minus 3. So that's still 6, but the bottom is negative 2 square root of 3. So that's 6 over negative 2 square root of 3. So that's negative 3 over square root. That's the slope there. So we get two two different slopes. And just FYI, there. If you look at the graph of this, let's look at the graph of that. What we got? T squared. And then T cubed minus 3T. Graph. Yeah, so this, be sure on this one I'm going to go T min, say negative 10, T max, positive 10, to get the full shape here, because by default it's 0 to 2 pi, it looks like. Yeah. And that doesn't necessarily give you the full graph. To get the full graph here, we need to go something like negative 10, positive 10 for T min, T max. That's what's called TIs anyway. Can't see those make, I think it's, anyway. Yeah, so this graph pretty interesting. Kind of got a little loop there. But anyway, what I was going to say is, so if I go to this, if you hit the trace, I believe we can go to square root of 3. Oh, it's right here. T equals square root of 3, we're right there. That point right there. Guess where we are on negative square root of 3? Right back there. The deal is, why do we have, this is a positive slope, this is a negative slope? Well, it comes in here, right? So negative t, t was negative square root of 3, I'm coming up this part of it. So I'm swooping in here. That has a negative slope, doesn't it? At t equals positive square root of 3, I loop back around, and so I'm on this side of it. That has a positive slope. Okay.
Is it just ironic that, like, isn't 3 over root 3 just